If you are going for technical interview or for your exam or maybe for Viva, then this video is going to be really helpful for you, because in this video we are going to do a quick revision of all the equipment used in a substation. Also, we will talk about what is this single ACSR Zebra and what is wave trap, what is this burst post insulator. Everything we are going to talk in this video. This will be a quick revision for you, so make sure you watch the video till the end. Now what you can see right here is the 145 by 33 kV substation section drawing, and we are going to talk about each of the equipment you can see here. So if you want to skip to any particular equipment, then you can check out the timestamp that I have provided in the description. You can skip to a particular equipment if you want, but we'll be going sequence wise to understand the equipment here. And here the distances that you can see are the minimum distances that you need to maintain between the two equipments, which is also defined by the respective standards. And that's why you will see that has been maintained all throughout all the equipments. So here is our first equipment, that is lightning arrestor. Now the substation that you can see is an outdoor substation, and there is a possibility that in case of lightning stroke, it can impact our equipment installed in the substation. Now in order to protect this equipment, we use a lightning arrestor which diverts the lightning stroke to the ground. Now it is basically a non-linear resistance which offers a higher resistance for lower voltages, and it offers a very minimum resistance as the voltage goes up. So that is one function of the lightning arrestor. It protects the equipment from lightning surges, right? The second important function is it also protects the equipment from switching surges, which is similar to that of lightning surge. The behavior of switching surge and lightning surge are quite similar, and hence you will also find lightning arrestors sometimes also installed just next to the most of the key and the expensive equipment like transformer, and this lightning arrestor is connected in parallel in the system. And the first equipment that you will see in a substation, it is a lightning arrestor. And this is also a very frequently asked question in technical interviews, that what is the first equipment that you will see in the substation? And the answer is lightning arrestor. So just to summarize lightning arrestor, the function of lightning arrestor is to limit the over voltages caused by lightning strokes, and it also limits the over voltages caused by the switching operations. Now what is the single Zebra ACSR conductor? Now this is basically a conductor that is been used in the substation. Now the name of conductors are given after the different animals for a strange reason. So the bigger the animal, the bigger is the diameter of the conductor. That is the understanding. So there you will see the name like single ACSR Zebra, single ACSR Moose, single ACSR Tiger, single ACSR Panther, single ACSR Dog. The bigger is the animal, the bigger is the diameter of that conductor. That is the understanding. So you will see a single Zebra conductor is used as a dropper here. And then there is a ACSR Panther conductor, this particular. And then there is a twin ACSR bus also used. So these are the name of the conductors. Now moving on to our next equipment that you can see right here, and that is CVT or capacitive voltage transformer. Now CVT is a type of an instrument transformer. Now what is the function of CVT? Let us understand that. So the voltage, incoming voltage, let's talk about this particular substation only. It is 145 kV. Now it is important for us to measure this voltage and also to keep an eye on the voltage level if it is increasing or decreasing. Now to measure this 145 kV voltage level directly, we will have to build a very big meters and very big relay, which make no sense and is also not the smart way of doing it. So instead of that, what you can do is you can step down this voltage and then measure it. And for that particular function, the CVT or capacitive voltage transformer is used. Now why it is called as CVT? Because inside it there are capacitors used, and that's why the name is capacitive voltage transformer. Now what it does is, let us have a look on that. So basically CVT it accepts the high voltage at the primary terminal, let's say 145 kV by root 3 because it's a single phase unit. And then at the output, it gives a much lower voltage, let's say 110 volt by square root of 3 or 220 by square root of 3. And then this input can be used either for metering and for relay, or both simultaneously. It is also possible. And for that purpose, capacitive voltage transformer or CVT is used. Now there is one more device which is called as inductive voltage transformer, or simply the potential transformer, PT. Now it is called as potential transformer because it is inductive in nature. Now this particular device is capacitive in nature, and that is the difference. Now another advantage with CVT is that it also supports in power line carrier communication. It is called as PLCC. It supports in that function as well. Now what is power line communication, that we will see when we will talk about the wave traps. So to summarize the functions of CVT, first of all, it is a voltage transformer which is used for voltage measurement, plus it also gives inputs to the relay for protection purpose, and it is also used for PLCC, that is power line carrier communication application. Now moving on, let's talk about the wave traps. Now in this particular substation, wave traps are not used, but not to worry, I have another layout where the wave traps are used. So you can see right here, this particular equipment is a wave trap, or it is also called as line trap. Now what is the purpose of this wave trap or line trap? So power transmission lines, they are just not used to transfer the electricity. It is also used to communicate between the two substations. So they are also capable of carrying the communication signal which is at a very, very high frequency, and that can vary from, let's say, 40 kilohertz to 500 kilohertz. So this signals with this frequency also gets transmitted via the transmission line. Now if this signal enters the substation, then definitely it will cause impact on the operation of the equipment, especially on the transformer. So to avoid this, we use wave trap. Clear? Understood? So what wave trap does is, wave trap simply blocks the high frequency signal. So anything, if it senses if it is 40 kilohertz or 500 kilohertz, it will block that particular signal, and it will only allow the signal which is at power frequency, and let's say which could be 50 hertz or 60 hertz. So it will only allow that particular signal to enter into the substation, thereby protecting the equipment which may be impacted because of this high communication frequency. So basically wave trap is nothing but a low pass filter which allows signals with low frequency and blocks signals with high frequency. So when the signals are blocked by this wave trap, then that high frequency signal will look for another path which they will find via the CVT, because CVT is offering them capacitance and it will flow through that particular capacitance. And hence I said in the previous few minutes ago when we talked about CVT that it also helps in PLCC communication. That's why CVT is generally preferred, because it can be used for dual application. If CVT is not provided, then generally the substation will have coupling capacitors. Clear? Again, that too for the purpose of power line communication. So wave trap is used to block the high frequency signals and allow only power frequency signals. By the way, if the video is helping you out, then do click on the like button and also do subscribe to my channel so that you get notified every time I upload the new video. And for that, make sure you also turn on the all notifications. Now moving on, let's talk about the next device that we have, and that is isolator. So this device right here you can see is an isolator, or it is also called as disconnector. Now the function of isolator or disconnector is to disconnect a particular part in the substation, and which allows to carry out the maintenance on it. So for example, let's say I want to carry out maintenance on this particular circuit breaker. So what I will do, I will first open the circuit breaker, then open these two disconnectors right here, and then I can go and carry out maintenance on this particular circuit breaker without any worry, because this particular portion is disconnected from both the ends in the system, and that is one of the application of isolator or disconnector. But people think that is the only application, which is not true. Isolators are also used to divert the power flow. Now, what is that? Let us understand. So here, let's take this example. We have two bus bar here, bus 1 and bus 2. Let's say bus 1 is our main bus and bus 2 is our backup bus in case bus 1 fails. Now here we have two isolators. Isolator 1 is connected to bus 1 and isolator 2 connected to bus 2. And below it, we have different equipments that we see in the substation. Now, when the situation is normal, bus 1 is active, and in that case, isolator 1 will be closed. So you can see the bus 1 is active, isolator 1 is closed, and isolator 2 is in open condition. Now, let's say there is a fault on bus 1 and bus 1 is not active. So in that case, what we can do to maintain the continuity of the supply, we can open the isolator 1, of course, after the opening of circuit breaker only, and close the isolator 2 so that the bus 2 will be made active and supply can be taken from the bus 2. And this is nothing but the rerouting of the power. We just rerouted the power from bus 1 to bus 2, and that can be done with the help of isolators. Now you can say this can be done with the help of circuit breaker also. Of course it can be done, but circuit breaker is expensive device compared to the isolator. Isolator is a very cheaper option available. So definitely isolators are preferred for this purpose. So the function of isolator in substation is to isolate a particular part for maintenance activity and also rerouting the power supply. This is really important, and please do remember. Now moving on, let us talk about the next device that we have on the substation, and that is current transformer. So here you can see this is the current transformer. Now what is the function of current transformer? Again, current transformer is one of the instrument transformer. Now the current rating that you will see in substation generally range from 1250 amperes to maybe 2000 ampere, 250 ampere, and in some cases it can go up to 4000 ampere depending upon the voltage rating. Now if you want to measure that current, then you will have to build a very big meters, very big relays for protection purpose, and that is again not the right way, not the smart way to do it. And hence what we are doing is we are stepping down that current and then measuring it and then using it for the protection purpose, and that's when the current transformer comes into picture. So this is the current transformer. Let's say the primary current is 1250 amp, 2000 amp, 2500 or 3000 amp, whatever it is, and then it steps down that current and it gives output as 1 ampere or 5 ampere, which is the preferred values given in the respective IEC standards. And then this output can be given to meter and to relay. So current transformer, the function of current transformer is for current measurement. The input is given to the meters, and then it also gives inputs to the relay for protection purpose. Now let us talk about the next equipment and the most important equipment in the substation, circuit breaker. So right here, this equipment, what you can see is a circuit breaker. Now circuit breaker is nothing but a simple switch that we also use on a daily basis in our homes. As we use the switch for turning on and turning off of the supply, in the same fashion, circuit breaker is also used for turning on and turning off the supply in normal condition. Now the biggest difference between a regular switch and circuit breaker is that circuit breaker is capable of opening huge short circuit current which can go up to 63 kilo ampere, and which is huge. Circuit breaker are capable of breaking this current as well. It has insulating medium which helps them in quenching the arc. So that is circuit breaker. Now always remember, all the circuit breakers including 66 kV and above are with SF6 gas as of now. Now people are also talking about the technology wherein SF6 gas will not be used in electrical switchgear. And if you're interested in knowing more about it, then you can go and watch my free webinar on that. I'll give link for that down in the description. It's a webinar on the future technologies. It's free of cost. You can join from anywhere. So SF6 circuit breaker is used from 66 kV and above voltage level up to 800 kV, and below 66 kV vacuum is preferred. So the function of circuit breaker in the substation is to switch on and off the supply, of course normal and also abnormal, and it also protects from the short circuit current, huge short circuit current. Clear? So this is the circuit breaker that we saw. This is again a isolator provided. Now in order to understand this arrangement, why isolator is provided here and here as well, we need to understand the single line diagram, or it is also called as SLD. And it is also important to understand the bus bar scheme that is used, whether it is double bus bar or whether it is 1.5 breaker scheme. That is important to know. You can check out my website courses.theelectricalguy.in to know more about this, and you will get some courses which will be explaining on this portion. Then again, there is a bus post insulator, or it is called as BPI. Now what is the function of this bus post insulator? Let us understand that. Bus post insulator is provided to support the bus bar right here. So you see here is one connection given to disconnector, and another one is connected here. Now if there is no BPI provided here, then the load of the bus bar will come on the terminal of this isolator and also on the terminal of this particular isolator. And these bus bars are heavy. We are talking about 145 kV voltage level, 245, 400 and more. So these bus bars are very, very heavy. And what it will cause is, it will cause unnecessary load on this particular terminal, and which can also cause breaking of that particular terminal. And hence, to avoid this, a bus post insulator is used where the gap between two insulator is high. Now let us move on and talk about the most expensive equipment in the substation, that is power transformer. So here is the most expensive equipment in the substation, and that is transformer. Now this particular transformer is 132 kV by 33 kV, which means it's a step down transformer. Now let us understand here the difference between 145 kV and 132 kV. Now 132 kV is the nominal system voltage which will normally remain in the system, and 145 kV is the rated voltage. So all the equipment that you will see here in the substation are rated for 145 kV voltage level. That is this part of standardization, and it is always a good practice to refer a voltage rating with its rated voltage. So instead of saying 220 kV, you should say 245 kV. That is a good practice. Instead of saying 400 kV, we should say 420 kV, right? That is the difference. So what this transformer is doing, it is accepting 145 kV as the primary input, and at the secondary it is giving 36 kV as the output. So this is a step down transformer. Now if the situation, let's say it's vice versa, primary is 33 kV and output is, let's say, 145 kV, then it is called as step up transformer. So the function of power transformer is to step up or step down the voltage, plus it also electrically isolates the primary and secondary. So you see in between primary and secondary there is no electrical connection, and hence it also isolates the primary side of the transformer and the secondary side of the transformer. And if you are interested in learning transformer in the easiest way, right from the basics, then you can join my course on transformer. I'll provide link for that down in the description. It is already helping so many students. I'm sure it will also help you out. So I hope you found the video helpful and you could do a quick revision of the equipment that is used in substation. If the video helped you, then do click on the like button and do also share the video with your friends. That really helps the channel to grow further. And I would really appreciate if you can subscribe and click on the notification bell icon so that you get notified every time I upload a new video. That's all for this video, guys. Thanks for watching. I'll see you in my next one. But till then, make sure you keep watching, keep learning.